All right, so the first thing I got to do is talk about the Help Me folder. So in your Help Me folder, right, chill. I should actually delete this. Huh? Yeah, they'll catch up. It is 9:08. I cannot continue to wait for them. So in your Help Me folder, hey guys, I'm going to keep repeating myself until I stop getting talked over. In the Help Me folder, yay. In the Help Me folder, there's now new content. There is a folder now marked Unit B, and I am using this anytime I work with one of your classmates. So, I was doing some adding mixed numbers with different signs. This is a problem from the Chapter 4 Progressing to Mastery. So all I did was point my desk camera down at the paper that we were working on, and it recorded everything we did. If you go into this folder, so you have to click into Unit B, that's why I said click into the folder. There's division with fractions of different signs, squaring a negative, and anything else that you guys come to ask me for help on, I'm going to record videos of it and post it up here. So if you are struggling on something and you think, you know, I bet my classmates are struggling on this too, check out the Help Me folder. I'm just going to post them as folders with, like, just so you can see the video. It's just so, like, the video is right in front of your face. There's nothing inside the folder. I just have to make it a folder so that it shows the video just like this, so it embeds the video. So check the Help Me folder, and if you need help, ask me for it, and I can make videos or things like that. The other thing is, yes, on my Facebook, the garage sale is this weekend, and because of the garage sale, I still don't have your tests to give back. I'm sorry. I'm going to try to get them in map during my planning period. Last night, we went and did pickups, and I did not get home until after 10 o'clock, and I had yet to eat dinner. Saw Ellie last night, got an exercise bike from her house. Thank you, Ellie. So here are pictures of the gymnasium right now. It is ridiculous. So you should be telling your parents, your grandparents, everybody that you know, gentlemen, here's your stack of computers and desktops. There is, now this right here is a phone that looks like a golf bag. But tools, if your dad needs any tools or anything like that, there's electric.
Do they just sell computer parts?
Probably if we got them donated. Rugs, couches, coffee tables, dining room tables. This was nice and heavy last night. That's a 3-piece entertainment center. So you guys can't really see right now. I just went and took these like 20 minutes ago. This is this morning right now. Here's games and toys. There's all kinds of board games and puzzles and like cars and things. So especially if you have younger siblings, there's stuff for like the younger girls. There's a bunch of bikes if you need a new bike or some bike parts. There's a ton of books and videos and things like that. There's baskets if your parents are into baskets. There's holiday decorations. There's housewares like glasses and bowls and things like that. There's just a different shot of tables and chairs that we have. This is a desk that's worth over $1,000. It is Amish made. The Amish make really good hardwood furniture. It is priced at $400 right now, and that's a killer price for this. That's seriously a steal. Art, there's a Captain America wall hanging for $4 if you like Captain America. Sure, I'll add Worthington, Ohio. So those are all the pictures that I have from there. But just to advertise and explain to you guys, it has been a very busy week here at Phoenix. So I do not yet have your grades into the map system. I'm sorry, I was just too tired. If you want me to be functional here to be your teacher, I can only stay up so late at night. So even with not doing your grading, I got to bed at 11 last night, which is still kind of late for me. I know you guys are like, oh, 11. Wait till you get older. You get more tired more easily. Jaslyn, you've had your hand up for a while. Hey guys, Solomon, notice how I just called on Jaslyn because she had her hand up. And yet you couldn't hear me because you've been talking incessantly since I put these pictures up. Can you please stop and respect your classmates? Can you? Okay, show me that you can. Jaslyn. Yeah. All kinds. Like whatever's been donated, it's just all random. So it looks like that one toolbox was from a plumber. There's a bunch of like plumbing type tools like pipe wrenches and stuff. But there's like hedge trimmers, there's saws, there's like all kinds of stuff. Yeah, I mean there's literally just all kinds of stuff. We're gonna we can only go 2 minutes on this, Jeremiah. Yeah, I think there's some TVs down there. It gets donated. I forget who we're donating to this year. I think it's Salvation Army or one of those places. and then they try to like either donate it to people that need it or sell it and make money for their organization. But we can't keep it any longer than this weekend. So we've been doing donations since Friday of last week. We started taking donations. So in a week, we get all these donations. Now, one of the reasons I'm bringing this up is we're going to talk about the math behind this, and it's going to be involved on your homework. So be aware, part of the reason we're talking about the garage sale is there will be problems on your homework based on the garage sale. Glenn?
Two things. One, how do you let people know that okay, so there's a big thing in there, but you can't haul it.
What do you mean?
Because you helped Ellie
Yeah, so we do those pickups on Tuesday and Wednesday, the week of collection. So we did those yesterday and the day before. That's why I've been really busy these past 2 days. It's been my entire evening.
Yeah, so do we just call you or something?
Yeah, but now it's too late. Our U-Haul's already taken back. So if you have something big, maybe save it till next year. But yeah, so that happens on Tuesday, Wednesday, the week of donations.
Also, can we, sorry.
Yeah, you're good.
Can we donate costume props? Because I would make some.
Yeah, I talked to Miss Rosie about that, but I would think, yeah. I mean, people would be interested in buying those. Anything that somebody would want to buy. You know what they say, one man's trash is another man's treasure? Elena.
You think they have, wheels and not just bikes?
I mean, you could buy a bike and then strip it for parts. I've done that before. I mean, the bikes are like $10, $15 maybe.
What?
Yeah, they're really cheap. Guys, we're trying to make lots of money, so what we do is we have a ton of items, and we sell them cheap. If you have few items, you have to sell them at more expensive. Our goal is $10,000. That's our goal for this year. Whitney.
How do you decide the prices of items?
That's a wonderful question. Our standard pricing algorithm that we are using on most items, the garage sale price, we're going to call that GP. You don't have to write this down. But the garage sale price that we set it at to start. On Saturday, we start to reduce some prices, and at the end of the day, Saturday, we sell things for pretty cheap. We've been doing, and this is going to be on your homework, 38% of the actual. So, we have a really nice Tiga ping pong table down there. Table tennis, really nice. I can't believe it got donated to us. Not, there's nothing wrong with it. It folds up, it wheels, it's awesome. It sells for over $1,000. So we don't want to sell it for that expensive. So we looked at 38% of the price, and I think we still went lower than that, because 38% was still kind of high. But that's the basic algorithm. So if we had an item that was $1,000 actual price, we would do our 0.38 times that $1,000, and that 1,000 would move my decimal 3 places, and that would tell me that my new price would be $380 approximately.
Right.
But still, that's a crazy deal, because what happens to a ping pong table when people play it? Nothing. So it's brand new. Yeah.
But how do you know the actual price?
We look them up online. We look them up. Because everything has an item number. Yeah, so we don't do it with everything. It's just the big items. Like that Amish desk, we search what an Amish desk would cost. We search what an entertainment center would cost. And we find something comparable. I don't know. Jeremiah? No. Sean?
The table tennis still there?
Nothing is able to be sold until tomorrow. Sale starts 8 a.m. tomorrow. Your parents can come. You will obviously be in school. So it's 8 to 3 tomorrow. And then Saturday, it's 8 to 2. At least I think it was 8. Crap. That'll pause the video because my screen. It's on. If your parents aren't my friend, they should be. But it's on the Phoenix PTSA page. There's a ton of info. But also, if your parents friend me, all of these pictures are on my Facebook. FYI, I've had a couple of 7th graders this year friend request me. I do not accept friend requests from students who are currently my student. That's not a good idea for you or for me. I don't want to see what you're doing outside of school, and really you don't care what I'm doing. It's just really nerdy and tree trimming and dumb stuff like that. So after you are no longer our students, then we will accept it and be your friends. But while you're our student, that makes our relationship kind of weird. So if you were one of those people who friend requested me, tell your parents to do it. I don't care if you see what's on my Facebook. It's just awkward for me to see everything you guys post, because sometimes it's I don't want to know about this. So I just deny those until you're not my student anymore. We got to dive into the lesson. We got to dive in. Talk to me later. I'm sorry. So we are having an origami competition. Who did some origami over with Mrs. Goldring? Yeah, and the multiple intelligences thing, depending on which group you were in, I think she had some origami paper. So, we want to talk about who won this origami competition. Now, what's the kind of hard part about figuring out who won this competition. You have a hand, right? I think you have 2 of them. Yeah, you can use them, right? Dom.
Well, it's hard because you judge it on multiple things, like who made the most intricate, who made the best.
Yeah, so it'd be really hard to judge, especially because they didn't all make the same amount of origami like structures. The lowest that somebody made was 8, and the most that somebody made was 15. So the judges are kind of going back and forth. How do we score this? And finally, some 7th grade student, very intelligent, walks up and says, we could use percentages. And the judges are like, oh my gosh, you're a genius. Let's use percentages. So we want to figure out what percent did they perfectly fold out of their total folding. So if we look at the happy friend, and this relates back to this Pearson video thing that's really dumb, so I just don't show those anymore because people told me like those are a waste of time. So if I look at happy friend, how do I figure out the percent that he folded correctly? Awesome.
I would do it because my brain works well with it, but I do the multiplication of 8 over 12 is equal to x over 100, so that's 800. 100 times 8 is 800.
So this poster right here explains what Manas is doing. We haven't really learned this yet, so you don't have to use this method if you don't want to. This is an option. So keep going.
8 times 100 is 800, so 800 would be equal to 12 times x, so you divide 12 because you want to get rid of the 12 and find out what x is.
Hold on. I need yellow, because otherwise this won't make sense. Yellow. Okay, continue. Then we divide by 12.
on both sides, and then that's x.
So we still have to do 800 divided by 12. So that's a little tough. But it works. It can work. What's another route that we could take for finding this percent? Tom?
Couldn't you do 8 divided by 12 times 100?
Yeah, any percent is just part divided by whole. Then you got to multiply by 100 to put it into percent form. So my part divided by whole here is 8 divided by 12, which reduces down to, do you know it, Jeremiah?
Oh, 2 over 3.
2/3, which that as a decimal, if we're getting good at recognizing our decimal conversion, what's 1/3? Tom? Yeah, 0.3 repeating, so 2/3, 0.6 repeating, then, go ahead. Because part that they folded perfectly, total that they folded.
Right there in the run area.
Yeah.
It was like,
This is,
Oh,
these are different problems. So hang on to your hats for a second. These are different problems. I'm just showing how the different methods get us to the same place. So when I get my 0.6 repeating, then when I multiply by 100, all it does is move your decimal, and we would get 66.6 repeating forever percent. If I do, I lost my, somebody stole my calculator.
How dare you?
Oh, it's over here. So I do 800 divided by 12. I get 66.6 repeating forever, except your calculator puts a 7 at the end because it's stupid. So regardless of which method we take, we get 66.6 repeating percent. Now the trick with Manas's method, this x value is the percent value. Using part divided by whole, we have to multiply by 100 to get it to percent form. So always make sure you're thinking through, does this make sense? So for Happy Friend, he's got 66.6 repeating percent. Figure out your percentages for the other 3 friends in the origami contest. On your own. I don't want to clear all of it. What's up? That black one? Nope. You are not allowed in there unless you are volunteering, and I think you need to have a parent. Tomorrow, after school, yeah, you can do whatever you want. There's no break tomorrow. It's Friday. Friday. All right, so cards. Sean, I think it was you who said, well, the second one's easy. Okay. But either way, Sean, because your card came up, how do I solve for my surly friend? Which, by the way, what does surly mean? If somebody is surly. We've got some students who like to be surly sometimes. Honestly?
Unagreeable and nasty.
Yeah, kind of unagreeable. Like if you know a friend who's kind of always grumbly and always complaining about things, like that's kind of a surly friend. If you're the kid who's like, hey guys, let's order pizza, and he's like, I don't like red sauce, or like, you know, they've always got something to complain about. So, Sean, bring it back. Bring it back. Sean, how'd you solve for the surly friend?
Well, first I did
6 over 10. What'd that give you?
3/5.
So you can reduce to 3/5, but actually we wouldn't want to. Okay, so yeah, you could get it to 60 over 100, which anytime I have something over 100, that something is my percent. So we see from there that that's 60%. Now the other thing that we could have done right here is identified 6/10 is 6/10 as a decimal, and then convert to percent by moving your decimal 2 places, and you get to your 60%. So our surly friend, you're doing he did well, but not quite as good as our happy friend. Positive attitude makes all of the difference. What about our new friend, Jaslyn? This friend that you just met? Sure, yeah. Dominic.
Yay! Okay, so you would do 4 divided by 8.
Yeah, so you identify. This is one where you wouldn't have to show work. So Dom, what did you reduce by, just so we talk it through? These can both reduce by?
They could be 1/2.
Well, but what do you divide by? Yeah, 4 to get to the 1/2. We know 1/2 is 50%. And this is kind of rude. But the person who's not your friend. It's just some person you don't know. Huh? No, I'm not going to change it. You just don't know who they are. Elena, what do you think? Hold up.
Colin Smith, the office, please. Colin Smith.
No, that's Mr. Smith. Is Colin Smith. But that sounded like Mr. Smith, so that was awkward. Elena. Can you what? Yeah. Whitney, how would I find the percentage for our not a friend? Guys, we need to stop with the extraneous comments and conversations. We gotta focus. That is fine. Noah? Do you know how to do this one? Okay. So, Andrew. So, especially if you were somebody that needed to pass this or didn't get to this yet, remind yourself that percent is always the part over the whole. Is 2/3. Maybe they are friends. All because somebody has a bad attitude doesn't mean that you can't be friends with them. Any questions? Elena, what are we doing? Because you passed my last question I asked you, and now you're going to pull out a book during my class? Kind of rude. I didn't go to college for 4 years for kids to read through my class. Actually, 4.5 years, if you're going to be technical. Yeah, but about math. Because literacy is important, and there's some really interesting articles about math. So,
Like kiss my math.
reminder of the process. If you are at all struggling with any of this percent work, you should refer back to this process right here to remind you how we get our percentages. We have a part and a whole. So say 581 students have curly hair out of a total of 1,932. I do that division to get my decimal. Once I have my decimal, I convert to a percent by either multiplying by 100 or just shifting the decimal, which is the same thing. Questions on that? That's just an example to make sure that you have an example to refer back to. Where? Oh, this because the zeros continue.
No, but below 14, there's 3.
Because, so it says like there is some math in there that they're not showing, and it turns into a 0.30. It equals approximately 0.30. Because I don't think that's perfect, but there's like some numbers out here that don't really matter. So they're saying there's some zeros and then there's some numbers out here. But since we're talking about percents, they don't really matter. Hey, Flynn, can you put that away, please? So then 0.30 becomes 30%. Because then I move the decimal 2 places. So actually, I hate having to do this, but can I see both of you after class, please? And I have like no time between class, so that's even more awkward. Try this. It's an election year, so this is very pertinent to what's going on right now. To be elected, our votes don't really elect the person. Our votes go to the Electoral College. They tell the Electoral College how they should vote, and their votes determine our president. So, in the Electoral College, there are 538 total electoral votes possible. They divvy them up depending on the state population. So, in 1976, Gerald Ford received 240 electoral votes. Now, depending on what you know about history, you might already know the answer to this. But the question is, did Ford receive over 50%? Show the math to support. Ozzy?
I have a question.
Okay.
Should it be 538 votes? I mean 539? Because if it's even, it'd be easier to tell which side won.
I don't know why they chose 538. I'm sure there's a reason. But if there was a half-half tie, which there never has been, it's been close, but I'm sure they would just do something to... I'm sure there's a process written down somewhere. Yeah, like, I'm pretty sure Pearson pulled, like, most of these reference problems are pulled from, real data. And, it was 76 that Ford was running for president. Remember, presidents can run, or, like, people that want to be president, they can run multiple times. So even if you don't win this time, you can run again. You have to be 35 to run for president. Good answer or what?
I have an
I'm
answer.
just giving time. There are actually 2 ways that we can solve this. So, Anish, if I asked you how you set this up, how did you approach this problem? Why?
Because it's you have to have more than 50%. So if I know how much 538 divided by 2, then I know how much 240.
Yeah, so Anish is saying, if I find out 50% of this number, I know how many votes he needs. So one way to calculate this, and Anish divided by 2, but I'm going to multiply by 5/10 since that's actually my percent. So I take percent times the whole. I figure out, what is that? Well, what's half of 500? 250. What's half of 30? 15. Half of 8 is 4. I add all these up, and I get 269 votes. So did he win? No. Now there's another way we can solve this. Are you trying to give the other way, Jeremiah?
I think so. So he got 240 votes, and I know there are 538 votes to you need to get more than half of 538. So I just multiplied 240 by 2, and 480 is less than that, so he did not.
Yeah, so actually, I guess I stand corrected. There are more than 2 ways, but the other way that we can look at this is what percent of the vote did Ford get? So the way that we really want to like be familiar with, that's great that you thought to solve it that way. Because so you didn't hear Jeremiah understand, he doubled this, because if this was 50% or more, doubling it will be more than 538, which it's not. So 4 did not win. The other way we can do this is just setting up the votes he got over the total votes possible to find out what percent did he win. You guys are more than welcome to use calculators at this point. When we get up to these bigger values, that gives us 0.446, and if I round, it goes to 1. Move my decimal 2 places to get a percent, and I get 44.61%. So that is less than 50%. He did not win. But was Ford ever our president?
Yeah. Was he?
Because I'm getting different answers, I'm going to leave that question out there. So what we found out is he was not president in 76. That doesn't mean he was never president.
Did he? I knew it. Yeah. There was a chart in like.
So now this goes back to the old style of schooling, not mastery grading. If you have an 85 gravity works, if you have an 85, come on, I meant out of class. When did he get elected, Ozzy?
You got elected in, No. 1974 to 1977.
We'll verify some information later. I don't know what page you're looking at. I'm not look, memorization is not the best way to learn. So I never memorized when the presidents were what presidents. Like, okay, so he was the 38th president. Sweet.
Friday, August 9th, 1974.
So apparently they kind of fibbed on their year. They should have done a little bit more research when Pearson wrote that problem. So on a multiple choice exam, there were 85 questions total, and you get 71 questions right. We want to know what percent, so now we have to solve for percent. What percent of the exam did this student get correct? So again, if you're having any struggles, would write out that percent is going to equal part divided by whole times 100. So then I set up my part, which was 71, divided by the whole 85. When I do that division, I get, and these decimal numbers are all very long, so you can round. On my homeworks, I normally ask for rounding to 3 decimal places after you made it a percent. So it's always safe to write 6 digits out. Because then, when I do my times 100, this is the part that some people forget, and there are trapdoor questions. I'm warning you now. So when I move my decimal for that multiplication of 100, I get 83.529. If I round, the 9 stays the same. Percent. So that student got approximately an 83. Depending on the grading system, that would be like a B or a C. Yeah, depending on the grading system, it'd be like a B or a C. Huh? It depends on if they do 7-point, 8-point, or 10-point grading. If you do 7-point grading, this would actually be a C. There's some, like the strictest grade system that most people would ever use is a 7-point system. 100 to 93, 93 to 86, 86 to 79. So it jumps 7 every time.
Why did you memorize that?
Because it's just sevens, chunks of sevens. But like over the summer when I do my summer school class, I operate on a 10-point grade scale because it's so fast. It's such a fast-paced course. Just 100 to 90 is an A, 90 to 80 is a B. I do. It's a get-ahead course. A certain survey, and we'll do some statistics later in the year, tells us that approximately 64% of people in the United States can roll their tongue. Roll your tongue. Some people can make a W with it. But it all depends. Your tongue is a muscle. Yeah, some really weird. Yeah, that's weird. So, How many people yeah, that W right there. How many people approximately do we say our school has? How many-ish in the 7th grade class? 84, right? So when we talk about Phoenix, we normally reference 165 students. Approximately, we have 165. Upwards, the most we'd have is 170. But I think right now we have like 166 or something like that. So we always say 165. So if we want to find out how many people can roll their tongue, would that be the part or the whole? The part, right? Because not everybody can do it. So we're looking for the part. So set up your formula. That part equals percent times whole. But remember, to use the percent, this has to be rate form. Our rate form is the decimal form of the percent. So I don't know my part. My percent, what does Eliana, Ellie, sorry, I need to change the names on here. I wrote them off the roster, so I'll go through and do nicknames this weekend. What does 64% turn into as a decimal? Yeah, 64 hundredths. Because remember, percent means divide by 100 times our school of 165. And when I plug that in, remember there are no partial people. So we're going to have to round to the most whole person. What'd you get, Julian? 105.6. So if we round, we get 106. Now wait! That's not what they asked me for, actually. Write the ratio of students that can versus the total. So a ratio is just a comparison of two values. Dom, do you know how I write a ratio? What I use between them?
Like the colon, or you can put like 162 or
Yeah.
many different ways.
There's 3 ways I can write this. Using a symbol that represents like a division or a comparison. So like Dom said, the colon. Or I could verbally say the word 2. T-O. Like 106, 2. How many students total? 165. A ratio is division. Division is a ratio, essentially. Yeah.
What if you have 106? Would you round down because 105.6 would be the 6 would round. The 6. Whoa.
That's what's dangerous about my chair being here.
The 106, the 0.6 is still only half, like a little over half versus so.
But wait, repeat what you just said. The 0.6 is, it's over half. So is it closer? We're saying, what is it closer to? 106 or 105? 106. You cannot break the rounding rules unless it's some situation where they tell you cannot go over a certain percentage. Like on my Skittles problem on the homework, I told you it was a maximum of 1%. And you actually got the answer of 12.34, which that would round down anyways. But regardless, if you rounded that up, you'd be over 1%. So there are some situations that you are not allowed to round up. This one you wouldn't round up anyways, because it's a 12.34. So be careful with your rounding. Make sure you remember the rules accurately. If you need any help, come see me. Try the got it on your own. Now you have to have a little bit of knowledge about our day to understand that. But pay attention that it is asking for the ratio, right? The ratio of hours a koala is asleep to the total number of hours in a day. You could probably do this without a calculator. You could probably do this without, or sin calculator.
Oh, I know.
Sin means without, calculator means un poco.
That means a little bit.
Yeah, that means a little.
Sí, señor.
Yes, sir.
Yo tengo un poco español. I don't know how to say skills. Or did. No, I took Spanish in high school. Most people do.
Yes. Did you take it in middle school?
Yeah, we took it here. We're gonna take it here.
Next year.
I want to learn an obscure language. I'm gonna speak Spanish. I want Italian. I don't speak basically no Italian.
Hey, Marty, can I speak some?
All right. Somebody that can do this without a calculator.
I can't.
Without a calculator. Ellie, what do you think?
Okay, so I think I took 75% and changed it to decimal to be 7,500. And I multiplied it by 24, which is the average in a day.
Now, are you able to multiply 75 by 24 without a calculator? It was a little hard though, right?
Yeah.
There's an easier way that we can do this. So I agree with what you did. What you did is fine. Shh. I told you guys at the beginning of the year, my goal is to make your life easier, right? I don't want you doing work you don't need to do. So how I can make this easier for my brain, I don't like long multiplication. I really like the array method better with the boxes and the boxes. And we'll talk about that a little bit more. But how can I make this easier, Julian?
Okay, so there's 24 hours in a day, so you divide 24 by 4.
Why?
Because that's 1/4. And
What's 1/4?
The
Why are you using fourths?
of a day. Because there's 75%.
What is 75% as a fraction?
3/4.
3/4. So the reason Julian is referencing fourths is we know that the koala sleeps for 3/4 of the day. So what Julian just told me to do was take 24 and divide it by 4 to figure out what is 1/4. Which was what, Julian? 6. So then to figure out 3/4, we just take 3 times our 6 that we just found, and we get
You get
18. So then, Evie, how do I write that ratio?
18 to 24.
18 to 24.
I didn't get how you got the 6. You got
We did 24 divided by 4.
Why?
Because,
It's divided in
guys, there are far too many side conversations. You're telling me that I need to alternate boy-girl when I make the seating chart. Because the boys cannot handle sitting next to each other. And some of you girls cannot handle sitting next to each other. The reason we're dealing with fourths is 75% becomes 3/4. So, we could either do 3/4 of 24. That's one route we can take, which is the same thing as doing 0.75 times 24. But instead, easier math is if I figure out what is 1/4, which this 6 that we found is our 1/4 of the day, because it's a 4. If we divide it by 4. I don't know any other way to describe how we got a 4th. We divide by 4. That makes a 4th. So that's a 1/4 of the day. The koala sleeps for 3/4 of his day. So he sleeps for 6 hours. That's 1/4. Another 6 hours is 2/4. Another 6 hours is 3/4. And then we make the comparison of 18 to 24. Sometimes I feel like you ask questions before you let your brain even think. So make sure that you take a moment to really try to process before you... I love your questions. I really do. But I feel like some of these questions you're asking, you know the answer to. More reminders of converting fraction to decimal and then fraction to percent, or decimal to fraction or decimal to percent. Use your notes on your homework. I can't tell you this enough. That's why I'm yelling it at you. Use your notes. So the last thing we want to do here is set up some example conversions that we should be getting very fast with now. I see 3/4. Well, we just talked about this. Ozzy, what is 3/4 as a decimal?
3/4 is 0.75.
0.75, because I could multiply both of these by 25 and get 75 hundredths. And that gives me 75 hundredths, which then, Ozzy, becomes what as a percent?
It's 75%.
75%. Flynn, when we look at 0.12, how do I say this properly? So when I look at this decimal, I don't want to say it because, well, I can say 0.12 because that's the wrong way to say it or not the proper way. How do I say this properly? Yeah, because I'm in the second decimal place, which is the hundredth. So this is 12 hundredths, but that's not reduced. We always have to reduce. They're both even, so the first easy thing that I see I can do is I can divide by 2, but then try to think of anything bigger than 2. Can I divide by 4? Yeah, that's nice and easy. So I get 3 over 25, and because 3 is prime, it is done. And Flynn, what does 12 hundredths become as a percent? We're not packing up yet. I'm sorry if you started. We're not. What is 12 hundredths as a percent? How do I... What? Yeah. So to go from decimal to percent, we multiply by 100. And that shifts my decimal 2 places. Multiplying by 100, the 2 zeros moves my decimal 2 places. So it becomes 12%. 175%. You should write these down. I'm not going to ask you. But that as a decimal is 1.75. As a fraction, when really we could just put 7/4 if we want to do improper. This last one is dangerous, so I advise you to write it down. This, when I go from decimal to percent and I move my 2 place values, I get 0.6%. That as a fraction is actually 6 thousandths, which becomes 3/500ths. Yeah, those small percents are really tricky to work with. On that, get out of here. I will see you guys tomorrow. Why? Because I yell at you to use your notes?
Yes.
I didn't say I never want to see you again. I said get out of here.